All right. Well, let's take a look at number 3. Will somebody read number 3 nice and loud for me?
I will.
Go ahead, Cameron. You ready?
Yes.
Number 3.
Mark is making a rectangular vegetable garden in his backyard. The rest of the backyard is covered with gravel. What is the area of the backyard that is covered?
Now, your image in your book looks like this. Now, we've got a full backyard here, John.
Sorry.
A full backyard that's covered with gravel. Now, I'm not sure if they don't like to mow grass, but they want gravel in their backyard, which is just fine. But right in the middle, they've got a vegetable garden or a garden. So is the whole backyard filled with gravel?
No.
No. They want to know the area that is filled with gravel. So the first thing I would say is, if you pretended that there was no vegetable garden here, how would we find the area of the backyard? Cameron?
75.
All right, we'd be finding the area of the rectangular backyard, which is 75 feet by 120 feet. So length times width for a rectangle. 75 times 120 is,
9,000.
TJ? 9,000. And what's our label if it's area? Feet what?
Square.
Area is always squared. So if there is no vegetable garden, they need 9,000 square feet of gravel to cover their backyard. But the problem is, there is this vegetable garden here. Okay, it happens to be 15 by 24. So if we're going to put the vegetable garden back in there, then how are we going to find its area?
What I did was I found the area of the entire yard of the vegetable garden, then I found the area of the vegetable garden.
All right, so let's find the area of the vegetable garden while you're talking about that. It's length times width, 15 times 24. And what'd you get?
I got 360.
Very good. So, okay, the whole backyard is 9,000 square feet. The vegetable garden is 360 square feet. So how are we going to find how much gravel we need?
I subtracted the vegetable garden's square feet by the square feet of the entire yard.
Very good. So the whole yard minus that one little part that's filled with the vegetable garden is going to give us the area of the part that's filled with gravel. And that just so happens to be 8,640 square feet. Anyone get that for number 3? No, Maverick must have. There's a couple. Very good. Does that make sense? The whole yard except for the vegetable garden, you need to make sure we take that part out. Okay? And the other one that I wanted to look at together was number 9. And number 9 has a question. It says, the length and width of a rectangle are each multiplied by 4. Find how the perimeter and the area of the rectangle change. Well, we actually did this together. We did it in our notes. Because when we practiced about when a shape is doubled in size, the perimeter is doubled. But when the sides are doubled, do you remember what happens to the area? If it's doubled. The area, who said it? Quadruples. It's times 2 to the second power. It's times 4. So I didn't just want an answer for number 9. I asked you to give us an example. I want to prove it. So let's take a rectangle. Anybody draw a rectangle that looks somewhat like mine?
Yeah.
Thomas, what were your side lengths? Because step 1 was to draw a rectangle. Step 2 was to label its sides. What did you use?
4, 9.
4 and 9. That's actually really proportional, because if this length is 4, that makes pretty good sense that this one would be about 9. So we labeled. Let's find the perimeter and the area of the original shape. That's Thomas's. That one's right there. How are we going to find the perimeter? If we walk around the outside of this shape, how far is it going to take us? How are we going to find our perimeter? Let's go, perimeter. Let's go. There's 3 hands up. You know perimeter, don't you, Ella? How do you find the perimeter? There's many ways. One way is to okay, there are 2 9s. And how many 4s? And there are 2 4s. So instead of adding 9 plus 4 plus 9 plus 4, which would work, Gabby's using the formula, you could shortcut. I'm sorry, Ella. Gabby might have used the formula too, but Ella used the formula. There's 2 9s, which is 18. There's 2 4s, which gives us 8. So the perimeter is 26. And how do we label perimeter? Inches. 26 inches is the original perimeter. And what's the original area? How many of these squares are going to be inside if it's 4 by 9? 1, 2, 3, 4, 5, 6, 7, 8. Oh, too many. How are you going to find the area? Cameron?
4 times 9.
Yeah, you want to count all those? Or can we just make shortcuts? The formula is length times width. Is it also inches?
Square.
Inches squared. All right, so we're up to step 5. Multiply the sides by 4. So the side that was 4, what is it now? 16 inches. The side that was 9 is now what? 36 inches. So we just multiplied the sides by 4, and let's find the new perimeter. Kind of like Ella did for the old one. Let's do 2 36s plus 2 16s. 2 36s, 72. 2 16s is 32. And we have a new perimeter of 104 inches. Thinking ahead to the area? What's our area? Length times width. 36 times 16. 576 inches squared. So now this brings us to a real question. We've got the proof now. We want to know what happens to the perimeter if you multiply the sides by 4. It was 26. It's now 104. So don't just tell us it got larger, right? We know it got bigger. How much bigger? How many times bigger? Let's do this. What's 104 divided by 26? How many 26s can go into 104? Alyssa? You're whispering, huh? 4. Very good. The perimeter changes just like the sides do. If the sides are times 4, then we know the perimeter is going to be times 4. The area, however, it was 36. And now it's 576. So again, let's work backwards. Let's divide. 576 divided by 36. How many 36s go into 576? Tristan? 16. And you might remember, the way we know it's 16 is because it's multiplied by 4 what? 4 squared. So when you change the outside, it changes just like the sides do. But when you change the inside, it changes to the second power. We went through this earlier, but times 2 for the sides. What happens to the perimeter? It's times 2. What happens to the area? It's times 2 to the second power, which is times 4. Logan, what's your favorite number? 7. So if the sides are times 7, the perimeter's times 7, and the area is times
14.
nope, times 7 to the second power, which is
49.
it's going to be 49 times larger. Okay?